So what I'm going to be talking about in this session is introducing the concept of and the subject of, and show you how to go about building RESTful web services with Synergy.net. And as I mentioned, if you were in the pre-conference session, then this is kind of a subset of that information. So bear in mind, if you do want to get more information about this, we will be releasing about 6 hours of video, the expanded version of this, with an awful lot more information and a lot more detail. So in this session, I really am going to keep it kind of to an overview and maybe not explain some of the concepts in a lot of detail, but hopefully enough to give you an idea of what a RESTful service is all about and how they work and how you go about using them. I'll show you an example of both how a service has been implemented, how a service can be tested in some simple testing tools, and how a service can be called in the context of a very simple application. What is a web service? A service, there's a couple of definitions from a couple of leading sources of information here. So Wikipedia says that a web service is a service offered by an electronic device to another electronic device, clearly devices running some kind of software, communicating with each other via the World Wide Web. So web services are not about human to server communication, they're about device to server communication or application to server communication. So this is essentially one piece of software, a client piece of software talking to another piece of software. The World Wide Web Consortium defines a web service as a software system designed to support interoperable machine-to-machine interaction over a network. So hopefully that gives you a concept of, or an idea of what we're talking about in terms of what is a web service. In terms of visualizing a web service, they are very, very simple things. There is a server, there is a client, there is some connection mechanism between the two. That mechanism is generally based on the internet, or at least internet technologies and internet protocols, so almost always HTTP. Not always. In the context of private internal networks, it might be some other kind of networking. Not necessarily HTTP, but some kind of TCP/IP networking, almost always, but that can vary. But certainly if we're talking about the web and actually publishing things via the internet, we're almost always talking about using standard HTTP or HTTPS protocols. Why might we want to use web services? Well, they really give us a way of doing the kind of things that you might do with component-based development, building a component to expose a certain piece of functionality and then using that component in the context of another application, be it something you build yourself or be it something you purchase from a third party to do a certain job, whatever that thing is. They really combine the best aspects of that reusability model with web-based deployment and internet communications. They give you a very good level of interoperability between different parts of a software application or between different software applications. They also give you a great level of platform and language, or they make you platform and language agnostic, because there's absolutely no requirement for a client and a server to be implemented using the same technologies, the same programming languages, the same APIs. You can actually totally develop the client and server completely independently of each other. Using whatever technologies you choose. They also give you a great way of coming up with and building decoupled environments. The client doesn't typically care how the service is implemented, as long as it understands the API and that API is consistent and doesn't change, then the client just makes the call however the service is documented. Similarly, the server doesn't care how the client is implemented. As long as it makes appropriate calls and passes appropriate data as required, then the two can interact. Also, web services can be built to give you great scalability. Again, assuming that you design the service well. Of course, you can destroy all kinds of performance and scalability by doing silly things within the service, but as long as you follow some good guidelines and some basic set of rules, then you can build very scalable environments. Multiple deployment options. Web services can be hosted by websites, by web applications, by servers like Internet Information Server or Apache perhaps. They can also be self-hosted in any other kind of application. So you might choose to, just because it's a web-based thing, you don't have to use a web server to serve it. You could build your own application to host it and run that application as a detached process or a Windows service or whatever you want to do. Really web services give you a great return on investment, because the real concept here is to build and expose the server functionality of your application one time And then you are able to consume that same functionality from any kind of client application, multiple client applications, and you're not duplicating anything on the back end. They're all just coming in through that one consistent API. What accesses a web service? We've pretty much talked to this now. So other software applications running on maybe desktop applications on PCs, might be websites talking to web services, other web services consuming web services. You know, my web service that I build to expose my line of business application might make use of other third-party web services that sell services that, you know, tell me about what zip code an address is in or something like that. You know, there's any number of online services, some of which are free, some of which are for pay, that you can consume. Frequently, you know, we all use mobile smartphones and stuff these days. Almost all mobile applications communicate with something in the cloud, right? What they're talking to is web services, almost exclusively. And very much more these days, the Internet of Things. You know, not mine, I don't own one, but at some point, you know, refrigerators that tell you when things need reordering and reorder your milk for you, and when your egg box gets low, you know, and so on. Devices around the home, electronic, you know, smart thermostats, all of that kind of thing. They're probably interacting with web services, and, you know, letting your smartphone's talking to a web service to get back to your house, which is talking to a web service and passing information around that way. How a web service is called, we've already really mentioned this, through ubiquitous web protocols, almost always HTTP, almost always for deployment HTTPS, the secure version of HTTP, occasionally via other protocols, but usually HTTP, and using some kind of data language, like in the older days with the older versions of web services, XML was very popular. A lot of the early web services used a pattern called SOAP, Standard Object Access Protocol, which is a dialect of XML, and modern web services, and certainly RESTful web services, still support XML, but typically use a data format called JSON, JavaScript Standard Object Notation, and we'll look at what that means very briefly. Primary use cases of web services, you know, you might use a web service to implement something that's a totally private API, whether it's within your organization or not, behind your firewall, you know, or a private API that you expose to the internet, and totally you control the client, and only your client will talk to that web service. And obviously you might be in the business of exposing public APIs. You know, you might want to expose parts of your line of business applications through a web service so that third parties can write their own client software. You know, you might want to expose an API that allows your customers to to inject orders into your business system, for example. You might choose to do that other ways, but a web service as a way of exposing your applications to your customers and your vendors and so on is becoming more and more popular. You know, I'm not saying it's going to replace well-established things like EDI, but it's certainly an alternative way of doing that. And, you know, maybe EDI is using more and more web services rather than private networks these days, and so on. In terms of web services in .NET, there's been a kind of a progression of various generations, if you like. The first generation of web services in .NET was back to the very beginnings of .NET, the 1.0 framework. There was something called ASP.NET Web Services. They were pretty simplistic in nature. They always used HTTP. They were SOAP and XML based. A lot of us developed those in the early days. They were those services that had the .asmx file extension. So if you've seen that in the URL when you're referencing something, then that's what you're talking to. Then along in the later days, in Visual Studio 2005 Framework 3 came something called Windows Communication Foundation. WCF was really a very extensive, very robust, very capable platform, and a lot of us in the room I know have done WCF in the past. Some of us still do. And it's still a very capable environment. WCF is usually also XML and SOAP based. It's the 600-pound gorilla. It's very, very capable. It's very flexible. It can do a lot of different things. But because of that, sometimes it's not quite so scalable, and sometimes it's a little bit heavyweight on resources. And WCF also takes an awful lot of configuring. In WCF, you write generic code and then do a lot of configuration to specify how it's hosted and where and what protocols are used and all that kind of stuff. So WCF can really take a lot of managing. ASP.NET Web API was introduced back in Visual Studio 2010 and got a major update to version 2 in the 2014 timeframe. So it's a framework specifically designed for hosting what are called RESTful web services. Now I'll explain what that means in a moment. There is no SOAP involved. There is still support for XML. There is no WSDL involved. It's very, very simple. It uses always only the HTTP transport. And there is a definite preference for using JSON instead of XML. Again, primarily for performance reasons. JSON is so much more concise than XML. It's also closely related to ASP.NET MVC, so it's a very structured environment where you're dealing with, you've heard us talking about MVVM, models, views, and view models. This is kind of the web version of that. MVC is model view controller, models are data models, views are the UI, controllers are like view models. ASP.NET Web API is very closely related to MVC, just without the views. So we deal with models that define data, and we deal with controllers that implement functionality, essentially, and I'll show you examples of those. ASP.NET Web API also is very, very nice to work with because it uses a lot of convention over configuration. So you follow naming rules and things like that, and by doing so, it is able to, the Web API environment is able to simply discover what controllers and models you've created and host them and stage them ready for use. With WCF, as I mentioned, you have an awful lot of configuration to do to actually expose endpoints that can be talked to. With Web API, all that goes away. You just literally write the code, and as long as you follow the naming conventions and a few other basic rules, there's very little configuration to do at all. It's very easy to learn, very easy to use. There's some great video resources out there on the internet if you're interested in learning it. Like I say, it's the latest progression from Microsoft in the web services world. It's all open source as well, and it really is a superb environment. A little bit about HTTP, just to give us some background, because RESTful web services are very closely related to HTTP and work very closely with HTTP. So it's important that you understand that HTTP is always a one-shot deal. The client sends a request to a server, the server does something, does some work, maybe builds some data for a response, and it sends it back, and that's the end of the interaction. Okay? So there is no persistent connection with HTTP, and that concept flows through into RESTful web services, and therefore through into Web API. One of the basic concepts of RESTful web services is you will be totally stateless. Okay, that's a requirement in order to be considered RESTful. A little bit of background. I'm going to skip through this fairly quickly because we are a little bit short on time. So an HTTP request consists of three things. And it is kind of important that you understand this, but as I say, if you want to get into this more, go review the pre-conference workshop videos after the conference, and there's a lot of information about this. So there's a request line that specifies what are you asking the service to do. That line begins with the method that's being used. Here you can see the example is get. So we're saying to the server, get, I'm trying to retrieve something. So this is how you would read information. And then a path on the server that says what are you trying to read, in this case customers and a customer ID. And then the final part of the request line simply confirms the HTTP version that's being used, which these days is pretty much always right now 1.1. Data can be passed, as you can see, we're passing data through the request line. You can also pass it using the more web-like mechanisms. Over here you can see the question mark ID equals is also a valid format. You can also pass multiple values with the question mark begins the query string, and then name, value, ampersand, name, value, and so on. So all of those HTTP mechanisms are still allowed and still work with Web API. There's ways of passing information in. The response line is a single line that comes back from any request that, as you can see, contains some critical information. Again, it's confirming the version of HTTP that's being used, but the important parts of a response are 200 OK. The really important part is 200. The OK is just a human readable part. So HTTP uses status codes. You've probably seen some of them around. So anything 200 is a success status. The few of the common ones are on the top right there. Anything 400 is essentially a client error. So you made an inappropriate request, or you're not allowed, you haven't authorized, or you're requesting something that doesn't exist. And anything 500 is a fatal error, a serious error. The frequent one you see is 500 internal server error, which basically is an unhandled exception. Some programmer didn't do their job, but that's what that means. So we're going to look at the HTTP response to say what happened. Did it work? Did it fail? What was the problem? Was something not found? That kind of thing. There are also these things called HTTP headers. Headers are simply name-value pairs that provide more information to the server or more information coming back from the client. And some examples there, you can see host www.acme.com is specifying which host we're going to be talking to. Content type application JSON is a way of saying to the server, I am sending you data and it's formatted JSON data versus XML versus an image versus a Word document versus a PDF, whatever it might be. And then there's every request, and well, not every, some requests also have a body, and the body is if you're sending data to the server, or if you're receiving data back from the server. Some responses do have a body, some don't. Some requests, some responses do and don't. For example, if you're doing a GET request to retrieve something, the request body is empty because you're not sending anything to the server, you're requesting it from, and so on. If you're creating something, then you would put the data for whatever you're creating in the body of the request. So the anatomy of an HTTP message, it physically looks like that. It's the request line, then the headers, and then the body if there is a body. And the example that you can see at the bottom of the screen is exactly what an HTTP request looks like going over the internet. Clearly you'd normally be using HTTPS for a live service, so you wouldn't see it in plain text, but that's essentially what's going on. These are examples of an interaction between a client and a server. So at the top in green it says get API orders 455320 host www.acme.com. There's a very simple request. It's going to go to that host. It's going to go acme.com/API/orders 455320, and the server is going to receive that request, presumably look up that order and make a response. Excuse me. And there's an example of the response you hopefully will get back. 200 OK, some headers. It's telling us I am responding with data of type JSON. And by the way, the length of that data is 107 bytes. And then in red there, you can see the data. So a blank line separates the headers and the beginning of the response. And then there is a response. This is an example of a post. So a post with RESTful services is used to create something. So if we're doing a post, we're saying to the server, please create orders, using orders. There's no ID being passed here because usually if you're going to create something, the server's going to determine what the order number is. So we're just posting to /orders. We're passing the headers saying which host we're communicating with. We're telling with the content type header, we're saying we are passing you data in the JSON format. And then it comes back with a response 201 created. And a good, following RESTful patterns, I'll talk about in a moment, it's responding and giving us some information as well. It's saying location. So to be considered RESTful, a post creates something. The correct response is a 201 created, and a header is required to give you the address of the thing that was just created. So it's saying if you want to retrieve the thing you just created, there's a URL that if you do a get, it will retrieve the thing that you just created. Or obviously we could parse that URL and just extract the order number, because that might be all we're interested in. There's an example of by the way, that was an example of a post which is a create. It's also, apart from the word post, an update of something would be done with a put. And other than that, it would be pretty much exactly the same. And there's an example of a delete. A delete is very simple. We're using the HTTP delete verb. We're passing a URL that has a piece of data. We're passing the required host header. And the response is extremely simple. It just says, OK, 204, no content. 204 is a success. 200 is a success with content coming back. 204 says, I did it. By the way, there is no data coming back. So equally, there's no body in the message. Very, very efficient. Very little data going over the wire to do these operations. JSON, you've seen some JSON in the example slides, but essentially JSON is just a textual format for representing data. It uses braces, brackets, colons, and commas to delimit data. Numbers are simply represented as human readable numbers, and pretty much everything in JSON is either declared as an object or an array of something. Okay? And there are only a few data types: string, number, there's a date data type, Boolean, and object. Again, you can get much more information on the other video about this. But as an example of a JSON object is simply a very simple name-value pair collection. So employee ID 100, first name Steve, last name Ives is an example of how an object is represented in JSON. An array can be an array of strings, an array of numbers, an array of mixed types. So you can see the third array there, 1 red 500. And it's also possible to have arrays of objects. So the example on the right there, you can see the brackets indicate the beginning and end of the array, and the braces indicate the beginning and end of each item of the array, each of which is an object that has properties. And you can have these things be in very complex hierarchies. Collections with a property with a collection with other properties and so on. That JSON is what's actually going over the wire, but we don't code that way. We code with just objects. So we created a model class that has those properties, and we code with those model classes, and then a class is serialized into JSON or XML to be sent over the wire. And equally, when a piece of JSON or XML is received, it's then deserialized back into an object. So rarely, sometimes you'll have a string variable with the JSON or XML data in it if you're coding a client. But if you're coding a server or a service, you just don't see it. It's hidden away, and Web API deals with it under the hood and does the serialization and deserialization for you. In terms of XML, the .NET framework has an XML serialization system built in. As you can see, it's named there on the slide. In the JSON world, there's a very, very commonly used framework called JSON.NET. That's available from a company called Newtonsoft, and it's available via NuGet. And Microsoft use that in all of their project templates as well. So you'll find that Newtonsoft JSON is already referenced when you create a Web API thing. And if you want to create a client, certainly in .NET, then everybody in the world uses Newtonsoft.json to do their JSON work, basically. Here's a simple example of how that happens. So you can see here we've got this variable called P that is a new person object, and we've initialized its properties to one Steve Ives. The middle line of code there basically serializes that object into a JSON string. So the variable JSON there, JSON convert is a .serialize object is a static method provided by Newtonsoft.json. It takes an object and returns a JSON string based version of it. And the line of code at the bottom is going in the opposite direction. So again, we're using Newtonsoft's deserialize objects. It's a generic method that accepts the type of person. So you say, please deserialize this JSON string to an object of type person, and P comes back as an object. So that's generally how you deal with JSON in code, certainly in the .NET world. Let's talk a little bit about REST itself. REST is a way of providing interoperability between computer systems and a way of implementing web services. REST is not like SOAP. SOAP is a specification. You have to do it this way. Environments implement the SOAP rules. REST is just a design pattern. It's a suggested set of rules that this is how you should go about building a web service. If you want that, if you want to create a really scalable, high-performance web service, here's a few suggestions of how to go about it. That's all REST is. You can take the advice or not. A lot of people take most of the advice and then apply a little bit of common sense and sort of say, well, we'll not quite do that. That's a bit strict. So you can interpret the guidelines in some areas, but generally the architectural goals are a good way of ensuring you wind up with a high-performance web service implementation. The 5 basic rules of REST, I'm not going to go into a huge amount of detail on, but one of them is you're a client-server environment. Well, that kind of makes sense. That's the goal in the first place. The second constraint is that you must be stateless. And that's so that you can be scalable, so that you can have a farm of web servers, and the first request might come in over here and the next one over here, and you don't care, and there's no state to get in the way of that. So almost all REST I've seen people breaking that rule, and essentially at that point they're not RESTful at all. They might as well use WCF. So most REST services are totally stateless on the back end, and every call is a completely discrete thing. That doesn't mean to say you can't have state in the server and store it away in a database and restore it and pass some ID around, but you're not passing the actual, so you're not maintaining the actual state in memory on the server. If the state, it's in persistent storage that any member of the web farm can access, for example. The third constraint is to be RESTful, you're supposed to be cacheable. By default, Web API adds the headers to the HTTP responses that indicate that the data coming back is not to be cached. But to be RESTful, you're supposed to apply logic to that and say, well, actually, this type of data, my product information only changes overnight, for example. So if you're retrieving information about products, you can go ahead and cache that for up until 9 p.m. tonight or something like that. And obviously, by doing that, the big advantage is you're going to avoid subsequent calls to the service to achieve the same thing. And you're going to have way less overhead, less network traffic, and better performance overall. So it is well worth putting some thought into being cacheable. Uniform interface basically means that your service should follow a set of general guidelines for what the API looks like, the format of the URLs and the naming conventions that you use. And there's a definite set of defaults that sample code when you create a new REST project, there's a sample service there, and it follows those patterns. And I'll show you those defaults on the next slide, in fact. And a layered system is basically, it's kind of closely related to the cacheable constraint. It basically means that the client should have no idea whether it's actually communicating with the actual server or some intermediary that's doing caching. Okay, so that's what that one means. So the idea is that by conforming to these rules, you get performance, scalability, and a really simple environment that is easy to use, and it really is true. Services violating any one of those constraints are not considered RESTful, but it doesn't mean it's not going to work. It just means maybe you're not following the guidelines as closely, and maybe you're going to give yourself some issues. But there are areas that I think it's okay to deviate from the pattern a little bit. This is basically how the default environment tends to work in a RESTful environment. So what we're looking at here is, there's obviously a base URL, www.myservice.com. There's a convention in Web API that all the operations tend to start /API something. Again, it's not mandatory, but after the /API, we would tend to have a resources URL, so that might be employees, orders, vendors, whatever it happens to be. And there's also a resources /ID, so /customers /57, /orders /10234. So you're either identifying a collection of resources, orders, or a single resource, orders /57. That's the point of those URLs. And then that is then combined with the HTTP request that you make. And there are 11 or 12 HTTP request methods, but REST uses 4 of them, usually, sometimes 5. And the ones it uses are get, post, put, and delete. And I think I've already mentioned that get is your way of retrieving something, post is your way of creating something, put is your way of updating something, and delete, clearly, update something, no, delete something. So in combination with what is the URL and what is the method that you're using, that's identifying exactly what you're trying to do. So for example, doing a get to /resources, or let's say a get to /orders, would retrieve a collection of all orders. Okay, that might not be something you want to do. So a post to /orders would be creating an order. A put to /orders/1 would be updating order 1, and so on. So a combination, as you can see there. Why use REST instead of SOAP? More open, reach more clients. SOAP services tend to be fairly complex in nature, although there's a lot of tooling around SOAP services. Very often, if you've ever done an add service reference in Visual Studio and pointed at a web service URL, it's easy to use as a developer, but what's actually happening is the developer tooling is downloading a WSDL for the service and then code generating thousands of lines of code for you that you then excuse me, you then instantiate and use. And that code is voluminous. It's huge and it's big and it's bloated. And that's part of the performance issue with environments like WCF. So RESTful environments tend to give you less overhead, less duplication, more standardized APIs, and more open because it's just HTTP and JSON. And that's just text and the internet. So any environment can talk text and the internet. So you can call a RESTful service from anywhere. You don't need specialized client software to do it. Building RESTful web services in .NET, as I've already mentioned. Oh no, I haven't mentioned this. It is possible to do it with WCF. There is a variant of WCF called WCF REST. It's kind of shoehorning the whole SOAP environment to make it look like it's a RESTful environment. It was not really designed for that, and it's not a great way of going forward, unless you're heavily invested in WCF already and you just want to do a bit of RESTful stuff as well. But if you're going to move from a SOAP environment to a REST environment, I wouldn't recommend doing it with WCF. There are third-party products. A couple of years ago, a very popular option was something called Service Stack, and I know some people in the room do use that. It's still a good option. It is multi-platform. That might be a consideration, although Web API can be too with the whole .NET Core environment. And ASP.NET Web API 2, I would say, is current state of the art. So if you want to look at doing RESTful for the first time, I'd strongly recommend Web API 2. This slide just re-emphasizes some stuff we talked about earlier, actually, so we'll skip over that one. We've already mentioned that Web API uses controllers and models. So here's an example of a controller. So this is how you define functionality in a web service. So you can see we've got a public class called People Controller that extends API Controller. So it inherits all of the Web API functionality, and all we have to do is expose operations. This piece of code at the top of here is simply exposing a hard-coded collection of data to test with. Here's an operation at the bottom. Public method get. That's one of the naming conventions. We're saying, in order to call this method, you do an HTTP get. Okay? And you'll notice it doesn't have any parameters, and it returns a collection of person. So there would be code in that method, and in this case, it's just M returning that hard-coded collection. That's an example of how to implement an operation in a Web API environment. So the method name begins with the name of the HTTP method. It doesn't have to. There's a way of using attributes to apply methods to names and things like that, but that's the default convention. And essentially, again, the name of the controller is relevant. People controller will be mapped to the URL. By default, it will be mapped to /API/people. If the URL begins API people, the request will be mapped to this controller, and the fact that you do a get method against it, the get method will be called, or the post method, or the put method, or the delete method. Web API models are simply data classes. Richard talked about data objects quite a lot in the previous example, and a data class is just a class that has properties that represent the data we're dealing with. So in this case, we've got a very simple person class that has an ID, a first name, and a last name. And you'll notice there are some attributes on some of those fields, like required, string length 15, and so on. That's an environment called data annotations that exists in the .NET framework, and Web API has a built-in mechanism to validate that stuff. So if you use those data annotations, Web API, with just a little bit of configuration, will actually pre-validate the data for you as it receives it. And if the client tries to send you data that doesn't follow those rules, it won't even call your method. It will just return a bad request error to the client. So using those data annotations can really simplify the implementation of web services. Validating inbound data has always been one of the hard things to do. Typically, you've got to run a lot of code to verify things. So requests are routed to controllers. So this is the naming convention thing that I just mentioned. Request to API/employees would be routed to employees controller. Request to API inventory go to inventory controller. And then the method is used to determine, and again, that's what this slide is talking to. So the HTTP method is used to map to a specific operation method within the controller. Web API is also somewhat self-documenting. It does require a little bit of configuration, and again, in the other videos, in the more extensive videos, there's some examples of how to do that configuration. But with a little bit of work, you can apply documentation comments directly within your model and controller classes, and those are automatically turned into HTML documentation by the Web API environment if you have that functionality installed. And it really does give you very good information. You can browse it as a developer and know exactly what services are offered, what data they accept, what data they return, and how to call them. It really is it's the recipe book for your service. There's also a tool that I'd like to recommend that you get into if you start developing RESTful web services, or even if you're consuming a third party's service. It's a great little tool. You can do a GET request in a browser just by typing in a URL, but if you want to test doing a post, a put, a delete, that kind of thing, and if you want to be looking at the values of headers and sending headers and things like that, it's just a little Chrome plugin. You get it from the Chrome store. There's a link, getpostman.com will take you off to the right place in the Chrome store. It's free. There is a paid version that does team synchronization and all kinds of things. But it's a great way of being able to issue HTTP requests and therefore interact with a RESTful web service without writing software. And it's a great way of testing your own services as well. So I'm going to show you a very quick demonstration. I'm going to show you the various stages of a web API implementation, and I'll show you a very simple client application interacting with that service. So the first part I'm going to show you is a model class. So as you can see, this is just a public partial class employee extends data class base. In data class base, as one of my classes, I've just got some little validation routines that help me deal with synergy dates and times and things like that. There's a .NET date to synergy date and .NET time to synergy time and stuff like that. And then we've got properties basically that represent the fields: ID, first name, last name, department, and so on. So it's just a very simple data class that's used as the mechanism. Essentially, this class defines the hierarchy of the JSON that we're going to send and receive to and from clients, because this will get serialized into a JSON string and deserialized back from a JSON string. So the property hierarchy of this class determines what the JSON looks like that's going backwards and forwards. This is, the example uses a repository pattern, not synergy repository. The repository pattern basically says, let's separate the business logic from the data access. So the employee repository is a simple class that simply does the I/O. So it has methods that simply, within the methods, you can see it's doing a select class to read all employees, or it's doing a select to read a specific employee and returns the employee object, or it's doing a get all the employees in a department. So this is literally just ISAM file I/O. Yes, I'm using the select class. Could I just do read S loops and stuff like that? Absolutely, it's just synergy code. Okay, so the repository class just accesses the files. Okay, and again, you don't have to do that. It's just a nice pattern. The controller class. So here's employee controller. We have a constructor. The example code is also using a mechanism or a pattern called dependency injection. So my employee controller class requires an employee repository so it can access the data. So it simply declares a constructor parameter of the type of the repository, and when Web API makes an instance of this controller to run some code, it will take care of handing the repository class into the controller. So I don't have to have any code in the controller that says make an instance of the repository class and manage it. I just say I need one of these, it hands it to me, and I use it to access the underlying data environment. Okay? And then we've simply got the operations. So get all, again, what matters is the name begins with the name of the method. So I've named this get all simply to make it a little bit more readable. So if a request comes in to /API/employee, and it's a get method with no parameters, then it will call get all. There's also a get by ID, so we have an ID parameter coming in, and it's mapped to an ID parameter in the route. So any request to employees/1 will get routed to this method. I've got multiple other GET requests as well, and I'm overriding the routing rules here. So what will happen here is if I do a request to /employee/department/sales, I will get all the employees for that department, and so on and so forth. Various other operations by last name, by state, by zip. Then we've got a post operation. So here we're receiving an employee in through the body of the HTTP request, and we're calling the repository's create method. And equally, here we're doing a put to do an update. And this code is just issuing appropriate responses if things go wrong. Invalid duplicate key, or yeah, okay. This code should be in the repository. This is dealing with the ISAM response. I've meant to take it out and move it, and I forgot. So that's the controller. In terms of the client, I showed you the other day a very simple Synergy command line client, which is still in this project, so that code will be there when you get it. I also showed you a Synergy DBR, a traditional program using the HTTP API. That code will be in the solution as well. Also today I'm going to show you a simple WPF client, just to show you the context of it running in a more realistic application. So it's a very simple application that simply allows us to, if I do a search, it came back with, it talked to the web service, deserialized the result and bound it to my WPF environment. Equally, if we do something like call the by state and do a search, we're going to come back with 126 from the service. And as you can see, it's nice and snappy and responsive. Now, it's a fairly small data model and it's all local on this machine, but RESTful web services do tend to be very responsive. Okay, briefly let me show you the code and see how that happens. The way this works is I've chosen, you don't have to do it this way, but what I like to do is wrap up the interaction with the web service in a class. So I've written a class called Employee Service Client that has all of the interaction with the web service, and then my actual WPF application just calls the method of that object in order to interact with the class. The class knows about the base URL, which is running on my IIS server. It's going to talk to the RESTful service that's at API employee, and it has various methods: get all employees, get by last name, get employees in state. These all return a collection of employee. So I wrote a single helper method, which is just down here, which actually does the interaction with the service. And all it's doing is it's using the .NET Framework's HTTP client class. It's formulating a HTTP request, setting the URL that's passed in, so in this case it's the base address /zip, for example, setting the method to get because I want to retrieve something, and then this line of code here makes an asynchronous call to the web service and waits for the response. And then I'm looking at the response code. I'm saying if response was status code.notfound, then I'm going to return an empty collection. So that's just my way of indicating there's nothing there. Otherwise, here's Newtonsoft JSON. So we're grabbing the response JSON string from the HTTP client or from the response, and then this is using Newtonsoft JSON to deserialize that into a collection of objects that simply gets bound to the grid in the application. Okay. In terms of the view model, it's simply, this is a method that is called when the search button is pressed, and as you can see, it's simply making a call through the web service client, get all employees or get employee by last name and so on. Okay, so very, very simple. It's just create an HTTP client, define the request, and call the get method or whatever it happens to be. Okay, so wrapping up, I've been involved with doing web service development for a number of years, since there was web service development really, with all of those iterations of tools that I mentioned earlier. And I just love Web API. I first looked at it about 7 or 8 months ago, I guess, late last year, and just immediately fell in love with it. It is so much easier than other environments, and I can't recommend it highly enough. Does anybody have any questions before we go for lunch? Okay, thank you very much. Enjoy your lunch.